1, 2, 3. Okay. One, two, three. Okay. It's time to start our webinar. Hello. Okay. You can hear me, I hope. Maybe somebody can write me a question or send me in the chat that you can hear and see me, so that I know that I'm not speaking to. Oh, thank you, Mohammed. Mohammed raised the hand. Oh, I see now. I have to check my settings. This is on the left side. Something happened here with my green wall. Like this. Okay, good. Now it's better. It's happened because a light here changed sometimes. Okay. Now it's going better. I think we can start in a few minutes. We have now a few people online. This is every time. We have sometimes we have 100 registrations, and on the 30 people are coming. So like every time 30% is coming from people that registered to this webinar. I think it starts now. It's time to start it. It's 2 p.m. Okay, for everybody who is on time. Okay, then we started. Hello, this is the beginning of my webinar, and my name is Andreas Kazmierczak, and as you can hear, I'm not a native US guy. I born in Germany, and I try to speak slowly so you can understand me. And what you see here in this webinar is my product, because Print to CAD is my invention, and CAD Direct is my invention too. And I'm the owner, 100% owner of the companies Back to CAD Technologies in the US and Kazmierczak Software GmbH in Germany. And today I will be speaking about a very, very special subject. This subject is conversion of PDF files from scanner. As you know, maybe you're an AutoCAD user. If you import this kind of PDF in AutoCAD is simply doing nothing. AutoCAD will extract you only this JPEG or this TIFF inside of your PDF file as external file and only make a reference in your drawing. Our program vectorize this kind of drawings, but not only vectorize it, we make a lot of recognitions, wall recognitions, text recognition, corner recognition. This is everything what I will show you, and you can get a perfect drawings. But very important thing, you have to activate correct parameters, because raster to vector is a very complicated task, and you have not only one kind of scans, you have a different scans with different drawings, and you have to tell to our program what is most important for you, what you expect from this raster to vector, and this is very important. And I will show you today a few files. This is not a presentation of a software. This is only online training, so that I take here a very wrong or very bad quality scans, so you can see how you can work with bad quality scans. Of course, if you have the good quality scans, the vectorization will be good. If you have bad quality scans, the vectorization, for vectorization, you have to take care of vectorization. You have to set correct parameters. Okay, then look here on my screen here. This is the program CAD, print to CAD, or print to CAD Ultimate, and here we start now PDF to DWG conversion. PDF to DWG. Okay, here you can choose a lot of files if you want, but I will choose only here this file. And let me start the analysis of the file. Before we view in the input, let's start the analysis. The analysis will tell you what you can find in this drawing. You see, this drawing can find 981 paths, so much hatches, so much text, and six different raster images. You see, and now you can go here on show, and we separate this elements and show you here a separate drawing. You see, these are 1, 2, 3, 4, 5. There are 6 different raster pictures in this drawing. And if you go here, for example, on show path, then we show you on a separated path, and you see this is everything on a polyline in this PDF. Or you can go here on view input. Okay, this is the same, and you can separate these elements here in the top, like separate characters. This is a native text. Separate path. Separate hatches. Separate field paths. This text, for example, is a field path. And separate raster images. You see, this is a raster image. This is not a native PDF. This is a text as a raster image, and this is a line as a raster image. You can, if you zoom it, you can see it. Here, if you zoom this L or this A, you can see this is not a native text. Now, if you go here on character, if you zoom it, you see this is a native text. And now, what's can happen? It can happen that your drawing is like this. That your drawing contains only one entity. Okay, and you go here on view input. Okay, you will see here there's no characters, no paths, no field paths, and everything is only one image. You can see here the border, the red border. This is the border of this image. If you go here now on analysis and start the analysis, you see this PDF contains only one raster image. There's nothing more. And normally, you can speak here about PDF. This is only a raster picture in a PDF frame. And now, if you want to import this PDF in your CAD system, you have to vectorize it, and you have to recognize with the help of optical character recognition the text, and you have to calibrate the coordinates, because the coordinates in raster pictures are in very, very bad quality. And this is what I'll show you. And after raster to vector, you can activate an optimization here. So the most important step is this one, raster to vector. Let me look again on it. And this is every time what you have to do as first. If you look at this drawing, you have to decide what is most important in this drawing, what you expect for this drawing. For example, is most important this building here or the curves? Because of course, in this building, you expect here the right corner that where maybe you recognize this is a straight line. But here you expect that we recognize here maybe the curves. And this is here something what you have to decide, because you can't activate curves for this part and right corners for this part. For this part, you can set parameters only for the full drawing. So now you can see, I will expect here that I recognize small circles, small dashes, okay, here the small dashes, and the curves, and I want to recognize the text, but you see this text is handwritten. It will be not easy to recognize it. Look here, for example, this comma is connected with this 5. And here, this point is connected with the 1. And now I will show you the most important parameter, if you try to convert this kind of drawing. Okay, the question is here, Mohammed, can you raise your hand if everything is okay? Because I see somebody has a trouble to hear me or maybe to see me. Is everything okay? Good, fine, thank you. You are my friend. Okay, good. So now the most important parameter, if you want to vectorize this picture, is threshold for the color black and white. Because vectorization or optical character recognition is every time made only in black and white drawing. And this is a grayscale drawing. And the correct threshold will be this kind of gray, what separate this black from this black. Like this color will be our threshold. And look, go here on color info, click on it, and you see this is not a grayscale. This is RGB hexadecimal, but this is about 40. Take every time the first number and remember it, 40. And now look what you have to do. Under raster to vector, under vectorization tree, you will find the program is using automatic calculation of the optimal threshold. But there's nothing better than you put your manually determination. It is, and you put your here, look, hexadecimal. I move it to the left, and here I put it on the 40. Now you see this gray will be black and this gray will be white. And this is now a perfect parameter. And believe me, this is the most important parameter. The automatic calculation is never so good like to look on this drawing and decide where is your threshold. Okay. Now we have the correct threshold here for the color black and white. Under vectorization 1, I have to decide what kind of vectorization I'm using. Okay, center line tracing, no. Okay, but outline, no. Solidization, like every pixel will be a solid hatch, no. What I activate here is a combination of center line tracing for long pixel traces and solidization for small pixel traces. How it works, I show you here. View video help. Here we show you how it works. For example, imagine you want to vectorize this kind of drawing. You can't use for everything centerline tracing and maybe right corner recognition, everything. Because you see, you have different elements here. So in first step, we separate in this drawing long pixel traces, pixel areas, middle pixel traces, and small pixel traces. And now, for every kind here, you have to use another vectorization. For this one, outline. For this line, center line tracing with right corner recognition. And here, we will apply solidization. You will see what this is. Like every element will be a simple solid, like here, solidization. This is what I'm doing now. And we are not interested in horizontal vertical lines. We are not interested in the 45-degree lines, but we are interested in circles and arcs. We don't have any pixel regions, okay? But here are the vectorization 4. This is something very important. Here you have to put these parameters, but of course it's not easy to know what the parameters are doing. Simple goal here. If you're interested in round R lines and curves, push this one. In edge lines, rectangles, corner, push this one. I'm doing now curves and lines and contour lines. Now, what I'm doing, after vectorization tree, I will place the raster image in a background so that I can see the vectorization, how the vectorization is done. Like this raster picture itself, I will put here in the background. Very dark and 30% transparent. Okay, and the vectorization 5. I want to recognize right corners? No, I'm not interested in this drawing. Small circles is correct. Small cross is okay, small dash is okay, but there's no symmetry. Switch it off because there's no symmetry in this drawing. Symmetry, you have only a lot of symmetry in architectural drawings, but not in this drawing. Okay, now I have the correct parameters and I am going here on optical character recognition. Let me look again on this drawing. The question is, do you really need the optical character recognition? What do you want to do with this drawing? I will show you first the conversion without the optical character recognition, and then next one with. Okay, so that we are ready now. We go simple on start. We convert the drawing. Okay, and now we'll check the quality, view and edit the file, and what's going on. Now the program starts our internal viewer. This internal viewer is a small CAD system. This is our own CAD system, CAD Direct LT. I have the full version Pro 3D, but you will get the CAD Direct LT, and you will find a lot of functions in this drawing what you can use. So, but that's not my subject. Look, we look here not to the conversion itself. Okay, I will regenerate the conversion. You see, this is like the smoothing was. This is recognition of the curves. But you see here what we get. Here you can see in the background the drawing itself. You can switch off and on this background so that you can see the quality of the conversion. Okay, now, okay, you can see we was able to recognize here the circle, the straight lines. This is a circle. This is a circle. Okay, and this is here a circle. Okay, and this is everything what we recognize. Now let me look here to the curves. Okay, for example, let me look to this area. Okay, well, this here. This you see now is perfect because this is and this is element solid. If you go here on properties, you feel this is solid. You can use everything here. You can change it, you can delete it, you can do what you want. Hit the background off, and now you can see. Oh, I have here a German. So you can move it. For example, you can go here. We can separate everything, and you can go on Edit, Move, and you can do everything with it. You can see. So this is how you can work with this kind of vectorized drawings. You can everything. This is not a native text, but you can do everything with it. Okay. Now I will show you how you can get another text, like how you can get here I switch it off. No. How you can get now optical character recognition, OCR, automatic optical character recognition, and I have only a horizontal text, and this horizontal text will be only as a raster image, and this is enough. I put here only my threshold here, maybe more to the left, so that I got here maybe this 40 again. This will be that we put here. Okay, and start. Now the program is doing not only the vectorization, but we are doing now the optical character recognition of the text too. But you see, this is a handwritten drawing. The optical character recognition is really very, very complicated, and you will see our optical character recognition will make a lot of errors. For example, here, we don't know what is HF, and we suppose it will be HE. Here I can put again HF. Here, we think that is up Q. Of course, it's not, then go on delete. Delete the optical character recognition. This is nothing, delete. So here you can correct a lot of errors, but the most important correction is here in CAD system itself. So look, so now you can see we make here a lot of errors here. We think that this is 111. It's not 111. You can see it. What are you doing here? Simple go here to back to CAD tools and undo the optical character recognition. Run it here and simple undo it, like here. Undo optical character recognition, and you get it. Here is something wrong. You can see this looks not good. Undo optical character recognition. Okay, and now it's like this. Here this was correct, so that you don't need to recognize, and this is now a native text, and you can work with this text. Let me switch now here the background off. So you can see we have here a lot of native text, and we was able to recognize in this drawing a lot of text. But of course, I told you that this drawing is very, very complicated. This is here mess, the undo, and you have to back. You see, to recognize this here as a text is very, very complicated, automatic. But there's another possibility. This is what I want to show you. If you have this kind of complicated text, simple go here under optical character recognition on enhanced optical character recognition. It takes maybe a little bit more time because you have to generate optical character recognition text areas. Okay. And now you can edit these text areas. What is text area? Text area is very important because the program knows that in this area, the program has to look for the text. And simple zoom everything what we suppose to be a text, and if it's not a text, simple delete it, like here. Delete, 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 this is not a text. Delete, 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 not a text. This is not a text at all. If you see something like this, let me zoom it here, okay, then you can correct it here. Look here, for example, you want maybe to recognize only this one. You can move it how you want here, okay. Here we have to separate two, and now number area, and this I have to recognize as number, and this is a number. Okay, zoom all, and here delete this one, okay, and yet we go here on zoom, because, and I will recognize this is a number, this is a number, and this as text area, and this is my text. Okay, so you see, in a few minutes, and I correct here a lot. Now go on save and edit. Okay, and you will see the quality of optical character recognition in this bad quality scan is now more better. Now, if you open the drawing, you will see you will get a perfect, almost perfect optical character recognition because we exact this delete. Let me do it. Delete. Okay, no, L. And here's HF, not delete. Okay, because we will see this is the quality is absolutely different. And if you have seen now, look, here I was able to recognize 30 and 4. And now you can see here 15 and 4. So no more the problems like before, because now you get here. Here's again mess. Okay, undo, run. Okay. Okay, this is what you can do if you have this bad quality scan. But I will show something more complicated, okay? Because we are now experts. Remove all. I will end the program and start again. So on this kind, you can delete every settings. But this time I will doing something different. Look, if you want, you can start this conversion in this viewer itself. This is what I'm doing now. new drawing, and this time I start the conversion here on the PDF import. The only one difference is if you start it under the CAD system, you can convert only one file. In this another case, if you start Print to CAD itself, you can convert a lot of files in one run. Okay, select file, and I will select for something very, very terrible. Okay, let me go here on my webinar, and here this drawing again. View input, and look, what is it? This is a terrible quality scan. This is not a scan. This is really a CAD system did it. Here you don't need to look for. Here you can trust the automatic determination of threshold, because you see this is almost black and white drawing, and because this is made by another CAD system, but you see the quality. This is a terrible quality because the resolution is absolutely not enough for raster to vector. Or here for optical character recognition, C connected with A. Let's go here, like let me here. W with I connected here. Silic, C connected with E, E with I, and with G. And here you need really artificial intelligence method if you want to recognize this revisions as revisions. You can see I will connect it with S. This is every time what we have to do if you have this terrible quality drawing, and I show you what you can activate in this kind of drawing. Okay, and look, for example, the walls. This is maybe what you want to recognize as an outline, and here you need a window. It's a center line tracing. Wall recognition is very important. Let me calculate here how many pixels we have. 1, 2, 3, 4, 5, 6, 7, 8. So here we have for the lines, maybe this was we need a line 1, 2, 3, 6 pixel, 8 pixels. You see every line has maximal 2 pixels. And this is what I'm doing now. Okay, raster to vector. Again, center line tracing and outline tracing combination. Automatic detection of pixel, but here I detect automatically the walls as solid. Horizontal and vertical line recognition. You can try here the double resolution during vectorization, but I don't really need this in this drawing. Okay. Now I'm going on vectorization 2. Here's nothing. This is everything for digital photos. Vectorization 3, threshold automatic, because this is almost black and white drawing. You can trust this then to automatic calculation. Only if you have grayscale or color drawing, you have to we need the manual determination of this optimal threshold. Vectorization 4. I'm interested now in edge lines, rectangles, and corners. Vectorization 5. I need to recognition of frame single and rectangle. We have a lot of symmetry, is fine. Right corners is fine too. But here I will increase the line width in pixels, maybe to 14 pixels. This is maximum line width, very important parameter. Okay, now I'm going here on optical character recognition. This time I'm doing again automatic OCR. We have horizontal and vertical text, but primary text, the most text is horizontal. Language is English United States, and our text is only as a raster picture. Threshold, don't take care here. You can put it how you want, because this is almost black and white drawing. Good, but now let me check the quality. Okay, start the conversion. And as I told you, this time I'm working under the program CAD Direct. Okay, of course the program is looking for symmetry, for walls, for symbols, for arrayed corners. It's take every time. Now you can of course here go through. Here is what we found in this terrible quality drawing. And here's what we suppose it can be. You see, it's not really from human to recognize that it can be title, but if you are able to recognize a simple write it here, and you can correct here, it is everything, here's date. Okay, now after this correction, go on, okay. In this interface, you become only the text if our artificial intelligence is in doubt what can be. And look, now we have a perfect drawing. What you see here, we was able to recognize the walls, the right corners, and the straight lines, and the text. And we was able to recognize the horizontal text and the vertical text. Of course, here we again mess up, but you know, simple go here and undo it. Here, something too. Okay, then simple go here and undo it. Okay, so now you can see we have here reunions. Okay, this is not correct. So you can go here and undo it. No, this will be the revisions. But you see, we was able to recognize the frame. We was able to recognize the straight lines and the text. And this is now almost perfect drawing. And we was able to recognize here the layers. If you go here, you can see we make a lot of layers, and we make here, see, we assign to every layer a different color. You can switch it off if you want, but we like it, this kind of conversion, because this conversion gives us a lot of information, so visual information, what kind of layers we have. But I'm going now to another last subject. Let me measure the distance. Okay, I'm going here on this back to CAD tools. First, what I'm doing here, you have to set the correct unit, because of course I put here inches and decimal. You can put your architectural, but you see this is, let me put here feet, okay, and architectural. Okay, now we have correct units here. But if you measure here something distance, let me check it, then you see this is not 10, this is only 114. What is it? This is a distance in plot. Every time after the conversion, you will get simply the paper dimensions. And now what you can do here, scale the drawing and tell our program that this is 10 feet, and the program scale it. And now if you measure this distance, let me check, so distance from here to here, you will get exact 10 feet. Can you see it? But if you measure this distance, okay, you will never get 5.4, you will get less. Why? Because the drawing itself is inaccurate. You make only the drawing bigger, inaccurate drawing bigger, but you didn't calibrate the coordinates. And now I will show you very, very important function you can activate here under this viewer from Print to CAD. That's the calibration of coordinates. I will calibrate the drawing using here the dimensions, and simply go here, measure the distance, and tell our program this is 5 feet 4 inch. And now go to next one, and this is 14 feet 8 inch. Next one, this is 6 feet 8 inch. And next one is 7 feet 4 inch. So maybe you don't see here a lot of effects here on the program itself, but you will see this function make a wonder. If you measure now a distance, you will get exact 14 feet 8 inch. If you measure this distance, 5.4. And look, if you measure this distance in the drawing here, for example, you will get exact 20 feet. Because the artificial intelligence method in this vectorization change the accuracy of the drawing, not only in the dimension itself, but in the construction itself too. For example, you see here, if you now measure this distance, this is exactly 40 inch. But what you can do if you don't have any dimensions in your drawing and you have this raster picture, this is our last subject, okay? You can use another method. This is what I will show you now here, maybe in CAD Ultimate. Okay, start PDF, choose file, and we take, let me take maybe this, we take this again, this number 5, okay? Now, again, raster to vector, walls, horizontal, corners, and frames, and everything is activated. This time I don't activate optical character recognition, so this is going faster, but this time I'm going here on coordinates calibration with the help of calibration points. You see, coordinates calibration with the help of calibration points. Here you can place in the converted drawing the calibration points itself. What is calibration points? Simple. You can choose any point here, like bank here, and you can tell this is the coordinate, this coordinates this, and we will calibrate the drawing. Now you put here one calibration point, boom, and this is the coordinate, and we will calibrate it. You can move it wherever you want. But you can see I deleted out here, delete. But you need here more precise calibration points. For example, you can put this calibration point here to the corner. So calibration point, bank, and I decide that this will be my coordinate 0, 0. And if you have this rectangle as a corner, we will snap this rectangle during the conversion. Okay, 0, 0. Now, if you want, you can go here in this corner. Okay. And here you can calibrate this point too. It will be 44 times, let me check it. Here you can, we put this in inch, okay? But this time you have to calculate 44 times 12. This is, of course, if you have metric, it will be more easy. I'm not really American here. 44 times 12 is normal. 44 times 12 is 582 inches. Also, X coordinate have the 5 to 8 inches, and Y coordinate have to be here 26.8. This is 26 times 12 plus 8. It have to be 320. So we have two perfect calibration points. But I will put another calibration point. Look, you can put the calibration point here. Here we have exact information. Let me put it here. And this time I calibrate only the X coordinate. The X coordinate is 10 feet, it's 120 inches. Here, the X coordinate is relative to last input, okay, 20 more, 240, and I'm not interested in Y. And the program automatically calculates here 260. So we have here a calibration point, here a calibration point. You can see you can calibrate is regarding X2. Okay, this is another possibility to calibrate an raster picture before you put it on the drawing, and put here a lot of calibration points. You will get a very, very accurate drawing. We have 1, 2, 3, 4 calibration points. Save and edit. Here are the calibration points, and start the drawing, and you will see how accurate is drawing now after I put in this drawing the calibration points. Very important thing is only if you want to use this calibration, please download the new program version, because there was one error, but we upload so in the past a few days ago and a correction. So, and you can, I'll show you after a few minutes how you can check for new upgrades. And let me check here not only the quality of the drawing. You see now this is a calibrated drawing. You can see the 0 zeros here, but look what we did. The calibration move the dimensions here exact. If you ask here with ID, the coordinates here, you see this is exact 0 0. Okay, and now if you ask with ID this coordinate, this is exact 10. Can you see? And if you see ID, if you ask now for this coordinate, this is exact. Look, let me check the drawing again. F2. 44, 44, 26.8, 26.8. This is how you can calibrate any raster picture before. So you have, again, you have these two calibration methods. One calibration method, again, is here in the program itself with the help of calibration points. Simply place these calibration points in the PDF and we convert it and take the coordinates. Or after you convert it, you can use the dimensions and calibrate it under the program here, this CAD Direct itself, and then we will calibrate later the drawing using these dimensions. These two methods are possible. Okay, and this is everything what I wanted to show you today. If you want this drawing, if you want this webinar as video MP4, then simply write us an email. I will send you the link. Okay, and Peter is now asking here. Could range the order of the options into the order the user should use as you described today? I think I didn't understand exactly the question. Please call me and tell me more about it, because I can't answer it, Lily. I need not really full understand it, but I want to show you something more here. Update check. Every time if you start a program, you can go here on update check, and then the program starts here and inform your version is up to date. So the version that we uploaded yesterday. If you have another number than 223, simply an update check and you can download and install the update. And again, with important information, if you want to use this coordinate calibration of raster pictures, you have to download the update, because we had a bug. The bug was corrected and now is everything okay. Okay, good. This is everything for today. I see Steven Venezuela is there. Hi, he visited a lot of webinars. And Peter, if you please send me my email, maybe email about your question, because I would like to answer you the question. If you have any question, send it now to me. If not, then I will finish this webinar, and next week I will speaking more about optical character recognition and spatial functions we have here in this email. Or if you go on our page backtocad.com, you will find this email. I show you something. Simply go on backtocad.com, back to cad.com. Okay, and here you will, under pages, for example, contact, you will find the contact mask, or here the email bcsales@cad-pdf.com, or you can send me here info about this message. Simply go on backtocad.com, backtocad.com. Okay, and then you find here a lot of emails, and here under pages contact you can send us everything. Okay, thank you very much. This was everything for today. Thank you for your attention, and see you next week the same time. Okay, I will give you more information about PDF to CAD conversion. Bye bye.